big telecom area, Carlo. Thank you.
Thank you. Thank you. Good afternoon. I'm Carlo Cavazzoni. I work in the technology innovation of Telecom Italia team. Today I'd like to not to talk about plans or what we are really doing, but I'd like to talk about a possible dream and about this dream. For obtaining this dream, I will describe a lot of issues, problems that have to be solved, and but I think that it could be interesting to share this idea to understand if the dream is only a dream or if it can become a reality in the future. So basically, the dream is in a very high level describing this scenario to have a federation of clouds between operators that could be able to offer to customer the same services, the same experience independently on where the customer is connecting or to which operators is connected. So if it would be possible in the future to have a federated cloud where the customer then can use their services in the same way independently on the location. This probably is a dream now, but I think that we should try to work in this direction, because this is more or less what the hyperscaler are providing to their customer. Inside the network of each operator, we have a very complex situation where the cloud infrastructure is fragmented in different levels depending on the hierarchy of the network, and we call this cloud continuum, and the idea is that the cloud should be able to be deployed in any kind of location, independently on the sites, offering always the same interfaces and the same experience to the application. We have a very complex situation where we have different kind of infrastructure, and so we should be able to manage a multi-cloud continuum, a multi-cloud infrastructure spanning through all the network of an operator. The first challenge is the possibility to sustain technologically this challenge, and what we have seen is that the current implementation for the telco application require a lot of customization, detailed customization to tailor not only the infrastructure but also all the requirements about the networking or other aspects of the application. And we have to move from this process, as already been said in the previous presentation, because otherwise this cannot be sustained. We have to move from the path approach to the kettle approach. We have to standardize the way the infrastructure are used by the application. There are many operational challenges. Also, this has been described well before, and the idea is that the platform based on Silva, as described before, should be able to provide on the north layer a common set of interfaces well standardized that can mask any customization inside the platform that every operator may want to implement for its own reason, but the important thing is that the common interfaces should offer the same primitives to any client for this platform. And the client of this platform could be the telecom vendors for their application, the customers, the engineering teams, or the orchestration tools that are requiring services to the platform. On the other hand, on the southbound, as Yoma described, the tool that seems the core package for guaranteeing the possibility to install the platform on any kind of infrastructure is cluster API that allows to implement Kubernetes cluster on private cloud like VMware, Red Hat, or bare metal, and in perspective also on public clouds. It has all the capabilities to implement this and to use any kind of infrastructure for deploying Kubernetes cluster. One important point is that we have to simplify the kind of infrastructure that we deal with, and we have to identify a limited set of really standardized private clouds, because we cannot be able to follow any potential small change. And also on the operation side, we have to try to select a common set of tools to standardize the way the network is operated and controlled. In some cases, this approach could have a price to be paid, because we may not be able to use some advanced feature that can be offered by some specific infrastructure or cloud provider. But I think that this could be accepted if these features are not really key to increase the value of the application. It's better to not to use some very advanced feature in change of a more standardized infrastructure to be used. One important point for obtaining the dream I described at the beginning is the collaboration between the operators. On one side, the tools that each operator uses for managing internally its infrastructure cannot be forced. But it's important to define this layer of common interfaces that mask in some way any specific choice of each operator. Then it is up to the operator to adapt the common interface to the specific tool that he has chosen. And also, we cannot expect the vendors to adapt to any choice of each operator, at least without paying it a lot. So the common interface should offer to the vendors a unique interface where their application can be installed, controlled, and so on. So this point is very important, the definition of a common set of interfaces to enable a federation of the clouds. And we think also that the adoption of the Kubernetes resource model, so to try to manage everything with Kubernetes or in the way Kubernetes works, could be really helpful in this direction. And this is the direction that we are following also in the Silva project. Another problem that has already been described before is the collaboration with the vendors, in particular to enhance the portability of the application. The portability is something that is not strictly related to the cloud native principle, but is an important thing because you should be able to move the application from one cloud to another without big changes. And again, the abstraction can easily handle the infrastructure customization. So through a common interface, you can define how to customize the infrastructure. For the management of the application, there are interesting activities in the NFV project on how to manage with the Kubernetes approach the management, the configuration of the application, not only for the infrastructure. But there are open points about the tools used by the CNF for their management and monitoring and so on. So we have to standardize the way that the CNF are monitored in a way that allows an application to be moved from one infrastructure to the other. And even worse is the problem when you think about networking and how to adapt the networking requirement of an application to a particular infrastructure. One thing that the vendors are usually doing and proposing is to embed everything they need inside the package that has to be used for the installation. In this way, the portability is better because you have already the tool installed, but then you have a big problem on the operator side because you have, as has been said before, to have people that are specialized for using each tool that each vendor has selected. So this is an approach that cannot be sustained. And so we think that it is important to have an efficient abstraction also for the monitoring tools, for the management tools, and everything has to be managed on the CNF. And we have seen in our experience that the major pain points is the networking. It's really difficult to implement all the requirements for the networking for a complex CNF. So it's important to have a joint effort in the standardization to define standard networking scenarios where the requirements are relaxed. And I think that there is a lot of work to be done in on these aspects. Then we have to put all these things together, and one point that is one thing that is done very well by the hyperscaler is to integrate tools for evaluating the cost of the application inside the infrastructure, and this is something that is not available in private cloud, and I think that we should try to introduce also inside the private cloud tools that are able to associate and assign the cost to each application and evaluate this in real time. And this is something that we are, for instance, starting to do on the energy cost and the energy measurements, and how to try to evaluate the energy consumption, associate this cost to any specific application or component that is running on the infrastructure. And all this data, together with an orchestration system with the mechanism of machine learning and artificial intelligence, should be able to evaluate in real time this data and change the configuration in order to optimize the cost of the infrastructure. This is my last slide, where I think that many open source projects like Silva, Nefio, or standard like ETSI NFV should cooperate together and create a community where all the actors, operators, vendors, integrators, can see together that there is a value in cooperating. And also it's important that we have from European community the initiative like the IPCI that can provide some resource to solve this problem and to allow the technological evolution to build this multi-provider federated cloud edge continuum. That maybe is a dream, and it will remain a dream in the future, but maybe we could follow the advice of the Martian to do one thing at a time, begin to do all the maths, solve them one problem. Maybe we will solve enough problem to set this success in this dream. Thank you.
Any questions?
Excuse me. Thank you. I think you talked something we haven't touched yet about the cloud continuum. So when you deploy an application, you can deploy any cloud, from edge, far edge to the center. If we really want to achieve the cloud continuum in the telecom sector part, I'm thinking 3 layers. For example, infrastructure layers. How can we achieve the cloud continuum? Based on Kubernetes, web assembling, OpenStack, and on top of them, there are, for example, now functionality. For example, today 5G UPF. If you want to do the continuum, you can do like a mesh networking by UPF has different connections at the edge, at the center, and then on top of the functionality, you have the orchestration. So you have to have some level of the orchestration in order to achieve the continuum. Is that so? Can you elaborate? Are you thinking similarly? Thank you.
Yes, what I'm thinking mainly is to continue on the infrastructure, because this is the way that could enable the possibility to install up to find for an application the same infrastructure, let's say at the level of the Kubernetes infrastructure in each location, in a big core data center, or in a smaller one in the edge, or in a very small in the far edge. then you need for sure an orchestration that is able to see the cloud continuum as a whole and have all the information that allows to make the choices on the best positioning of the application, for instance, in order not to leave the positioning of an application only to the customer, but to receive from the customer an intent request to optimize some parameters, some aspects of an application, and then the orchestration intelligence is the one that, knowing the network and its current status, is the one that is able to select the best position for deploying this application.
Okay, this is a good vision of the scenario. Thank you.
Thank you, Carlo, again.